In the two previous lessons, we determined the x and the y intercepts of a linear function using technology and using the algebraic method. We determined it algebraically as using your graphing calculator. We could use, and we also use Desmos. And also we use the algebraic method. Today we are moving into our second and third goals, which is to solve problems involving the x and y intercepts of a linear function and to recognize the limitations. So today we are beginning focusing on the first and the second and third goals in this lesson. Now, in some word problems, it does not make sense to use negative numbers. If we look at our x and y intercepts here we have negative numbers, or the x-axis is negative, and the y-axis is negative. Sometimes it's not necessary. Other times it is, and that's the limitations to it. But, for example, here we have a rocket follows a path of 3.54 plus 7.25. This is the path it takes, an equation of a straight line, where the x represents the distance from the launch pad and y represents the height. So two graphs are shown. Here in this graph here, both graphs show the equation accurately. So here you have the equation, the exact equation demonstrated here, and the next one over here. But you'll notice the second graph is better because you cannot go back in time. This means negative time. Unless you're living in some quantum world, it's possible, but here is negative time doesn't exist. So this is a more realistic model of this rocket leaving. It's just represent the distance above the ground, this horizontal distance far relative to the ground. So graph 2 is a better representation of the situation of this rocket, the path of the rocket taken. Now, remember our goal is also to look at the limitation of x and y values. Sorry. That refers to the domain and range. Remember, when we talk about domain, we're looking at the graph here. Where on this graph where on the x-axis this graph exists? And if you look at the domain here, this graph goes to the left forever and to the right forever, because the arrowhead indicates there's no ending to it. So we can conclude that the domain here is from negative infinity to positive infinity. Or we write it as x such that x is an element of real numbers. There's no restrictions. This is what we call interval notation. It's a set notation. The range now refers to the y values. So if you look at this graph here, this line goes forever, x, and go down negative. So we can say the range in this case is from negative infinity, from here, going up to positive infinity, or y such that y is an element of real numbers. There is no restriction. That's what this set notation is indicating, or the interval notation. So in graph 1, we can write it as this form, or as I've written it here, graph. So we bracket x such that x is an element of real numbers, close bracket, and the range can also be written as y such that y is an element of real numbers. So there's no restriction in the domain and range. But the more realistic one is this graph 2, which shows that the graph begins at x equals 0 and y equals 0. The graph begins here at x equals 0, but at y, somewhere between 2, 4, 6, 8, somewhere between 7 and 8. Okay. So let's look at a domain. This graph starts at 0 and goes to infinity. So we can say x is greater than infinity. Sorry, a greater than 0. So this is a limitation of domain. We can say x is greater than 0 because it doesn't exist beyond 0 here on this graph. Then we look at the y values, and notice this graph begins somewhere between 7 and 8. Now, if you were to look at your equation, zoom out a little bit here, we know if we have an equation written in this form, that's your y-intercept, 7.25. So this graph starts from 7.25 here on the y value. So this is 7.25. So that's why we could write the range as y is greater than 7.25. So be careful about writing your domain. So the domain, so here we can say domain is only valid for x values. So we're looking at x values equal, right, and greater or greater than. Oops, 38 greater than. Let's write this properly here. Than 0. That's this is moving greater than or equal to. So equal to or greater than 0. The same would apply for here. The range. So this graph doesn't go to negative. So the range is only valid for y values. So let's emphasize that, right? The domain is for the x values and the range is for the y values. So this means where y is greater than, is equal to, so you can say greater than or equal to 7.25. So that's your domain and range. So that's your restriction. Okay, so be careful about that. So we're looking at actually problem that refers to that. So we can say the domain and range in graph 2 is restricted because the rocket is only moving forwards from the starting point. So the starting point is from here. It's moving from there. And it's launched from a height of 7.25. So it's above the ground. So this is your ground level here. So the launch pad is 7.5 meters. So high. So it's pretty high. It's above the ground. So this means above ground level. And it increases from that value. Once it's fired, with the rocket booster, it goes upwards, but also horizontal distance. So it's traveling relative to the Earth, horizontal distance. So it started from, generally this would be your horizontal, where you're starting from, which is 0, but the height above ground is 7.5. So this is your y-intercept, remember that, your y-intercept. And which is the height of the rocket. So the height from which the rocket was launched. So the height the rocket was launched. So having this in mind, this is the background. We will look at a question that take into consideration the domain and range, a restricted domain and range. Okay, so we're using appropriate graphs for application of linear function. So we're going to look at the restriction here. Let's look at this question here. And here we're going to apply the graphing calculator. Now, a ball moves from a rooftop to the ground according to the equation. So you're at the top of a roof. Let's say this is a building here. Okay, so the ground. Oops. So a ball moves from the top of a roof to the ground. So a ball is dropped. So you have to drop someone drop this ball, and so it's going down, and it's falls somewhere there. So this would be the trajectory of the ball. Now it doesn't go in a straight line. In reality, it goes into a curve. For those of you into physics. But here is your equation. V stands for the vertical distance, which is the height of it. And H refers to the horizontal distance. So we have two things here. V, the vertical distance, and H, the horizontal distance. Okay, so look at your equation here. This is your equation, V. Now, remember we have a general equation of a straight line, y is equal to mx plus b. Now, if we use this model of equation of a straight line, so your b is 12.5, your slope is negative 3.5, right? Because this is your m, your x is the h here. Now, recall your y-axis now is your v. So we can translate this. This becomes your v, which is your y-axis. Therefore, your x-axis is h. So we can actually label our x-axis now, change it into an h. That's horizontal distance, and we can label it this now as a horizontal distance. The v is your vertical distance. So we'll write that this way here. Now, your vertical distance and the horizontal, they're both in meters. So we'll put an n here, and we'll put m also there. So we've labeled our x and y axes. Okay. Now, remember I mentioned to you, right? A ball is thrown off this roof here. So we will not look at a negative distance. So we'll start from 0 here. So we are restricting our domain. Now, the height at which a ball is dropped, we will find that, which we'll use our calculator to find the height. So essentially, you are dropping this ball. The ground distance is the horizontal distance. This is we refer to the building. How far from the building does this ball drop? We know the height, which will give us our y-intercept. Let's answer some of these questions here. What does h represent? Horizontal distance, it tells us here. So let's look at that. Horizontal distance. The v represents a vertical distance. Now, and these are all in meters. They tell us they're in meters. M in bracket indicates meter. What does the v-intercept represent? Now we're going to look at it now. So if you look, let's go to our equation. Now we're going to go to our graphing calculator. And we're going to input this equation into our calculator. So let's try that now. Y is equal to, now we are going to change the v to y. So we're going to change this equation, make it look like y is equal to negative 3.5x plus 12.5. So calculator, you could do it as v and x, but it's much easier to write it in this form because it's an equation of a straight line. So we're going to write that as negative. Now I'm going to zoom out so you can see my key function. So remember my negative here, not the subtract sign there, 3.5x plus 12.5. Now, notice I see nothing. But remember my graph here, I'm starting from 0 here. Right? So I'm going to go to my window, and I'm going to change my x minimum here to 0. Now, my x maximum, I want to go as maybe 20. Let's try 20. I'm doing a guesstimate here. And then my y minimum now, I'm going to be 0 here. Okay, go to my y minimum. You only play around with these, minimum 0, because you're not going below ground. This is ground level, right? And the height of the building, well, let's make that 20. This is my graph. Notice I have too much now. Notice the value here. So I have too much of my x values here. So I'm going to go to there and I'm going to change that to maybe 10. My x maximum. And my y max, I went up too high. The building is not so high. I'll make that 15. So my graph looks a little bit closer to reality. Okay. Seems to have an excess. So now let's label this point here. We're going to label this as 1, 2, 3, 4, 5, 6, 7, 8. I have up to 10. And you can go on if you would like. And going up here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Probably stop there. But you can go much further, the vertical distance. Okay. What does the V represent? The V represents intercept now. Where's the V intercept? Where it crosses the y-axis. Let's find the y-intercept here. That's your V. So second trace, remember your work in finding the y-intercept? You go to second trace, value, let x be 0, y is equal to 12.5. That's 12.5, indicates the height of the roof. Okay. So the V represents the height of the roof, right? In other words, from ground here, so the height is 12.5. So the height of the building. Which is 12.5 meters. So we have our y-intercept there. Now, the x-intercept, where this point here, let's find the x-intercept. Let's see what that means. So we go to our calculator. We already I already inputted here, y equals 0 here. So that's fine. So in my graph. Now I'm going to find where it crosses the x, this blue line crosses the x-axis here. Now the red is still there. If you want to see it a little bit further, I can change my window and maybe have a -1 for my minimum y. I'll check -1 so you can see, okay, your x-axis here. Right. So now this will be your x-intercept. Now, what I did there was simply to change my window setting, my y minimum. So I went below 0 here on the y-axis. I put y as -1. Here I have x is from 0 to 10. And y, now I have -1. So I put on here -1. Now, in my graph, I have 13, and here that's 15. So I'll make that 13 exactly what I have in my sketch. Now I can graph that. It's almost exact replica of what I have here. Now I need to find my x-intercept. So I already found my y-intercept, which is the height of the roof, height of the building, I should say, sorry. And this is your ground, right, level. So when it hits the ground, it will be your x-intercept, which is 1, 2, 3, between 3 and 4 meters. So let's try find second trace, intersect, and I move down. Oops. The first curve. Oh, sorry about that. Second trace, intersect. Now I want to go, I think I went too far down. Now notice if I didn't see it, right? I look at my coordinates here. Here my y is negative. So it means I'm way below here. So I need to move up by pressing the left arrow key. And eventually I'll see that cursor. And there it is. Because this cursor here was way below the x-axis. Because if I look at here, I can see it. Y is -1, but x is 3.9. So it tells me that it's way under the bottom right of the calculator. So to go up now, I press my left arrow key, not this arrow key here. See, it'll move all over the place. So I move up. So I want to find the x-intercept here. So put enter, enter, enter. And that gives me 3.57. So around here, 3.57. This point here is 3.57. So I'll take my calculator, my ruler, sorry, and I'm going to draw a line here. Now it begins and ends here, right? Because that's your rooftop is up here, and this is your ground. I just want to indicate that's the arrow here, 3.57. What does the h-intercept represent? The h represents the distance on the ground from the building, right? So this is the building. So the distance, so we can say here, the distance on the ground from the building. Okay, so the distance from the building at ground level. So here we are the ground level, so the distance which is 3.57. So we found that. How far is the base of the building, the ball land? So we say it's 3.57 meters. And how do we get that? We said we let y equals 0. We calculate. We already have our equation y equals minus 3x plus 5. And then we go second trace. We do this part here. And we go 5 intersect, and we enter and 3 times. And that will give us 3.57 meters. Now, the question is, does the graph continues forever in both directions? And the answer would be no, right? Because at the ground level, the ball would hit the ground. Can it go any further than the ground? Unless you were to dug a hole, and an endless hole. No, because the graph begins from the rooftop here and ends at the ground level. So the answer would be no, because the ball was dropped from the roof of the building and stops when it hit the ground. when it landed on the ground. Okay. The next question asks, what's the limitation of V? Well, it's the height of the building. Limitation, because if you were to drop it from the building here, the height of the building is a limitation, because you cannot go higher than the height of the building unless you have some kind of crane. But in this case, we have the building, right? So the height of the building is a limitation. And the ground, well, the ground level, the ball will stop when it reaches the ground, right? Ground. So we said we have here ground. The ball will stop when it hits the ground. Unless you have some powerful forces within you that will cause the ball to go into the ground forever. But no, so here, all kidding aside, that's your answer. Now notice how our limitations are the height of the building and the ground. And that explains that recognize the limitation of x and y values contextual problem. Because the ball cannot, you cannot drop the ball higher than where you are on top of the building. Okay, you're on top, that's the highest point. And the ground where it lands on the ground. So that's where you recognize the limitations of the x and y value. You solve the problems, so we solve this problem here. What height of the building and where it lands on the ground using the equation of a straight line. So today's lesson, we solve problems involving x and y intercepts, and we recognize the limitations. Just a little bit of review. If you were to write this at the domain and range now, the domain is restricted here. The domain is from 0 to 3.5, and the range is from 0 to 12.5. So if you were to write this to the domain now, so the domain would be x is greater than 0 and equal to 0, and x is less than or equal to 3.57. We'll do more of this as we go further into problem solving, and the range is y is greater than 0 and equal to, and then y is less than to 12.5. So this is your limitations. Right? Your limitation is greater than 0, but it's also less than 3.5. It's between. That's the way of writing it, is between 0 and 3.57. We can generally write these all in one. We can say that x is between 3.57 and greater than 0. So that's one way of writing it, domain. And the same thing for the range. So you put these together into one. Okay. It may look a bit challenging at this point, but as you get more, if you do many of these, you become more familiar with the word. And this is where y is less than or equal to 12.5, and it's greater than or equal to 0. Oh, sorry, with x here, and this would be y. So this is domain and range. Right in this form. Previously, it was written as all the real numbers because there was no restriction. Here we have restrictions. Okay. So you may want to try question number 3. in your booklet,